Hi everybody, so today we're going to do a short video clip on the mole and some mole calculations. So the mole has always been something that has been quite abstract, and sometimes it can be a bit confusing to understand what we mean exactly by the mole. So in chemistry, the mole is a quantity. So it's a little bit like comparing it to everyday substances. So you may say something like a dozen could be 12 lots of bricks. And that is a set of 12. 2, 4, 6, 8, 10, 12. Now instead of calling it 12, you would call it a dozen. Exactly the same as in chemistry, you have a set quantity. Particles or atoms are very, very small. So if you're going to describe however many particles there are, these numbers could be quite huge. So it actually makes it a lot easier by grouping them together in a certain number and calling them the mole. So let's have an example. Calcium. If you remember, atomic symbol is Ca. The relative formula mass is 40. And remember, the relative formula mass is found from the periodic table. And you could say that this is the same as saying the mass of 1 mole of calcium is 40 grams. Similarly, you may have seen these for other examples as well. So calcium carbonate. Here we go. Chemical formula CaCO3. Try and remember, capital, 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 lowercase. We have calcium, that's 40. And if you want the total mass, you obviously need to check the periodic table, the atomic number. We discussed this in an earlier video. You add the atomic number for carbon, which is 12. You have 3 oxygens. Now oxygen is 16, you times it by 3, and the total value is 100. So this is also the same as saying the mass of 1 mole of calcium carbonate is 100 grams. Now, this tells you in terms of the equivalent masses and relative formula masses, how they are linked, but it doesn't still really describe what the mole is. So Avogadro was a scientist who did lots of work around this, and he wanted to really find out what sort of quantity of particles we're talking about when we're discussing the mole. Now don't forget, when we're talking about particles, we don't just mean atoms. We're talking about molecules, and we're also talking about ions. Now the number is this. So this is known as Avogadro. Oh, it would help if I spelt it right. Avogadro's constant. There we are, folks. So Avogadro's constant. 1 mole of a substance contains the same number of particles as 1 mole of any substance. So essentially, we need to require ourselves to remember this value. So Avogadro's constant is 6.02 times 10 to the 23 per mole. What Avogadro is telling us here is that this is the number of particles inside each mole. Now that's a huge, huge number. So what we're really saying, if you remember, standard form tells us that we need to move this 1, 2, and then you're going to continue until you've reached 23 jumps, as I like to call it. So that is the equivalent of 602 Wait for it. How many have we got? 6, 10, 11, 12, 13, 14, 15, 18, 20, 21. There we go. Let's see if we can see all of them. There we go. So you can imagine to try to say all of these would be quite huge for every single calculation. So you can just refer to this as Avogadro's constant. It's the number of atoms, molecules or ions in 1 mole of a substance. So let's write down this particular definition. The number of atoms or ions in 1 mole of a substance. And this is your Avogadro's constant definition. Okay, let you have a look at that there. So this is the number of particles that are in 1 mole. So the amount in moles can apply, as I said, to atoms, molecules, ions, and even electrons as well. So let's have a look at a question. We need to calculate the number of particles that would be in a substance. So you know the constant, which is this, 6.02 times 10 to the 23, and you also will be told the amount of a substance in a mole. So there is an equation that you can use to calculate the number of particles. So let's write this down. The number of particles is the Avogadro's number, or Avogadro's constant, times the amount of substance in moles. Okay, so let's have a look. So imagine we have a question, quite typical, calculate the number of water particles, or rather water molecules, in 0.5 moles of water. So let's write that down. So we want to calculate the number of particles. So calculate the number of water molecules. There we are. Number of water molecules. Just my camera in 0.5 moles of water. Okay, so first thing you're going to use is this constant, so 6.02 times 10 to the power of 23, and then you're also provided with the amount of substance in moles, which is 0.5. So you're going to multiply that number by 0.5, and this gives us 3.01 times 10 to the power of 23 molecules. Really important. We are not looking at the individual particles, because remember, water is made up 3 particles. Okay, so that would be, of course, I know you know this, H2O. If you wanted to know what this value would be for the individual particles, you would simply multiply this by 3, and that would give you 9.03 times 10 to the power of 23 atoms. Okay, so I hope this video has been useful. In the next video, we will be looking at how to calculate moles using the mass and the relative formula mass number. Thank you.